So we're just waiting for some people that are still logging on. Hi, Frank.
Hello, guys.
So I guess we should get started. It's 10 o'clock Central European time. So thank you very much for your time this morning, everybody, to attend the webinar titled "How to Build a Future-Ready Telecom Visibility Strategy." My name's Paul Brett. I'm the responsible for Cubro's business in the UK, Ireland, and the Middle East, and I'll be your host today. I'm joined by Fabian, who's a product and solution engineer based in our headquarters in Vienna. And also joined by Adrian, who is a solutions architect based in the UK with an EMEA-wide responsibility. So what we wanted to cover today very specifically was to talk about some of the considerations that can impact Telecom's network visibility planning, including product security and security compliance, what we see, the increasing network speeds over time in the industry, and the associated cabling challenges that come with that. And finally, just to talk a little bit about some of the technology choices, and specifically around what are the challenges with deploying white box solutions. Before we move into the detail, just a couple of housekeeping things I would like to mention. We'll have a number of polls and questions that we'll be asking. We'd really appreciate your response and feedback to those. We'll also have some resources available for you to download as well. And finally, if you have any questions, we have a Q&A session at the end, but please feel free to answer or ask any questions as we go, and we're happy to field those as we move through the presentation. So I guess that's the housekeeping out of the way. Let's move to the first question, and that is, how do I know Cubro devices are secure and won't cause compliance issues in our network? So I think, Fabian, maybe you can pick that up, please.
Yeah, thank you, Paul. So hi and welcome from my side as well. Great introduction, Paul. Yeah, let's start with the first question. So the following couple of slides will show some very high-level internal guidelines, how Cubro develops, plans, and releases new software components. So this includes, of course, the main software components of our network packet brokers, but also stuff that normal users don't see, like libraries, kernel drivers, and other parts that belong to the full picture of embedded hardware. Our values, quality, features, and security contribute to improve the overall user experience and cement the customer's trust level. So this flowchart is an actual internal process, which is very much simplified, of course, that we run through every new product and firmware release. The key parts are to define expectations based on the market research we do, the user feedback that we get, for example, and the value and risks that comes along with it. So the upper part of this slide is discussed and planned by the head of support, such as the lead developer of the particular product category. And once we define the critical part, we command the development team or teams who run through that plan and realize it. The Cubro product and solution engineer, here it's mentioned as the Cubro, the product owner, are monitoring the processes and chat daily with the team. This involves reporting after reaching some milestones and in parallel preparing testing and user documentation. Before the actual release or publication of the new release, a detailed test is executed and protocoled. The following aspects can be used by the product owner within the monitoring of the development process. For example, that the goal of the development or a particular deliverable is still in focus, that the code is standardized, that major changes, for example, those that affect other parts of a product which other developers are working on, fit well. So the synergy is working very well. That information security aspects are enforced, and that coding guidelines are followed, for example, concerning coding and naming styles that are agreed on, and of course, commenting formatting, so that everybody knows the code very well. The reviews can be accelerated or replaced if the code in question is already covered by automated tests for packet brokers or software components. The reviews and the resulting measures are documented in any case. Code that is not produced in-house needs to be carefully selected and reviewed in terms of quality and security. As said, each new software version needs to pass internal acceptance tests before it is published. The tests are split into two major parts. First, each software version needs to pass functionality tests. The test person in charge is determined by the product owner. During these tests, all relevant features of the whole product will be tested, for example, filtering of a packet broker or stripping or other functionalities of the device. The second part contains additional security tests. Here, the whole software release will be tested against automatic tests with tools like Tenable Nessus, if this is known for you. After that, we also do testing against the checklist. We see that in the next couple of slides. So the checklist that includes all past, but also known new attacking points. All tests must be, of course, documented. Only if both of the criteria are considered as passed by the product owner, the software release can be delivered to our customers. Maintaining the security of our systems is a top priority, and we use a comprehensive checklist as a guide to ensure we consider every possible vulnerability. This isn't about checking every box, but rather about using as a mental framework. Okay. So keeping software up to date, big point. Fundamental step is to ensure all software is current. So to say, we define up to date as a version officially supported by either the main developer or the Linux distribution. This is especially critical for core components like the Linux distribution, kernel drivers that are third-party compiled, and essentials applications, standard applications such as SSH to manage the device, SSL libraries for encryption. We also focus on other key areas like web servers, so this is an interface for the customer, sudo privileges, so the super admin privileges, let's say, and all applications with open ports or vulnerability possibilities. We must always validate user inputs to prevent common attacks. This is clear. This includes verifying that software upgrades are signed, ensuring our logging prompts are secure. There cannot be code sent via the user interface, and of course protecting our REST API, which is another interface to the unit from malicious requests, for example. Additionally, we establish strong practices for handling sensitive data like passwords. We never store static private keys on a device. Passwords are never stored in plain text. Instead, we use strong hashing mechanisms with random sorting, and we have very strict guidelines there as well. When evaluating new libraries or dependencies, we discuss all options with our security experts to evaluate its sustainability for this use case. We question several factors, including its popularity, the code quality, the community support, security practices, best practices, testing and documentation before making a final decision. Our risk assessment is a very essential point in this flowchart. There are such cases that not all defined acceptance criteria can be implemented. Therefore, a risk analysis needs to be done. This analysis should show the likelihood of occurrences and the consequences of those parts possibly not being realized. But there can also be certain possibility vulnerabilities or scalability challenges which cannot be addressed in a reasonable manner. The product owner cares for good documentation of risk assessments. The product owner and the executive management will decide whether to accept the unresolved issues or to restart the requirement phase. To protect our source code, we host it on our own secure GitLab server in Vienna. The server is physically protected and has high security standards, including automatic updates. All connections to the server are encrypted using either HTTPS or SSH with public key authentication. Thank you.
Great. Okay. Well, listen, thanks, Fabian. Very interesting insights there. And I guess if I just sort of summarize my understanding of that, then robust company information security and product development processes are essential to ensure product security and security compliance, certainly in modern networks. And it's probably worth pointing out at this point again that, of course, Cubro have ISO 27001 information security management accreditation, as well as 9001 quality management accreditation as well. So I guess that brings us on to the next challenge actually in modern networks is around the ever increasing speeds of those networks. And the question we're often asked is, how do I handle the increasing speeds from sort of 10 gig up to 400 gig, and also the associated cabling challenges that go with that? So again, Fabian, would you like to pick that up?
Yeah, thanks. So the Cubro network packet broker lineup is very strong and offers a lot of flexibility. Let's look at some of them that offer multi-speed support. So we have one of the very latest packet brokers is the Cubro Packet Master EX48800, which is the top one, the black one. It supports 48 ports of native 25 gigabit SFP28. All of these ports also support 10 gigabit speed, so it's perfectly fit to upgrade from existing 10 gigabit network packet brokers. And also the last 4 SFP cages here also supports 1 gigabit speed. Additionally, we have 8 ports for 100 gigabit. One of our flagship models is the Session Master EXA32400. So Cubro has very early expanded in the 400 gigabit market and the technology, which we are already very successful in with a lot of customers and got very positive feedback as well. So we have a 32 port unit with 400 gigabit. So this is very powerful. And within the next couple of slides, that of course, area of this port can run also in 100 gigabits and also in split mode to reach other port speeds like 10 gig or 25 gig. So we have a very wide port range on these two devices from 1 gig to 400 gig. Of course, no problem to stack the unit, connect them via cables, depending on the interfaces to your network from LifeLink perspective or span ports to have 10 gigabit, 100 gig, 400 gig interconnections there. And also, of course, the interface to the analysis systems, whether this only supports 40 gig or 100 gig or still are low bandwidth 10 gigabit pro tools. We all cover that on this unit. So it's a very powerful lineup that we have. Of course, there are many others packet brokers on our homepage. You can check it out. But these two one of the latest ones, and give very powerful lineup already with the ports. As said, each of the ports, of the 100 gigabit ports of both units, can be used in the so-called split mode or breakout mode. What does it mean? On the UI, you can select every port and put it into split mode, for example, splitting it into 4 virtual sub-interfaces. These creates 4 visual ports you see on the bottom there that can be independently used then in the web UI for forwarding traffic, so receiving traffic or sending traffic out. And they can be then 25 gigabit, 10 gigabit. You can also do 2 times 50 gigabit. And on the 400 gig unit, of course, you can use 4 times 100 gigabit. So if you multiply now 32 times multiplied by 4, you have the number of 100 gigabit ports in this one U device actually. You see also here our 64100 port using this scalability function, as I said, gives you the very good advantage to insert it in your network, for example, for covering a lot of 10 gigabit or 100 gigabit ports, and then scaling it later up to higher bandwidth. So if you have a lot of 10 gigabit interfaces to be covered today, you can use an EXA64100 here, 258 10 gig interfaces if you use all the ports in breakout mode, and then transition to 100 gig on the fly on the same units, no problem, by just putting some of the ports back into the normal non-split mode to use 100 gig. And then the same you can do in the 32-400. You have a couple of 100 gigabit capabilities, and then slowly upgrade to 400 gigabit without changing the unit. So it's an investment in the future by using these devices on the scalability. Each of the ports can be used as input and output simultaneously. If it's a split port or a normal non-split port, this does not matter. You can use it freely. We don't differentiate into network ports and tool ports. You can freely mix it. Let's look a little bit more closer to breakout. How can this be achieved? Very common are these, on the right side, these octopus cables or breakout cables or whatever you want to call it, where you have an MPO connector on the one side, a single connector, which then leads into 4 full duplex pairs of LC connected. And this cable basically splits the channels inside of the MPO cable, which are already existing. These 4 channels, for example, in the 100 gigabit, uses 4 times 25 gig modularity there, and the cable gives you the inside fiber cables, the channels out of the LC connector, and you can put it into an SFP plus module. So, for example, you have on the Cubro packet broker, you have the 100 gigabit port with a QSFP 28 module. And then you connect this breakout cable into the 100 gig SFP, and then on the other side of the cable you have these SFP modules, 10 gig or 25 gig. You can connect these LC ports there, and on the Cubro packet broker you select then what ports to send the traffic to, and exactly these interfaces will get the traffic as it would be a normal 10 gig or 25 gig port. Additionally, below you see the breakout box. This is Cubro's slimline chassis for breakout. So instead of using this breakout cable or octopus cable, we have this breakout box, which basically includes 4 breakout cables. And you can use traditional normal cables here to connect on the right-hand side the MPO cable, female-female cable, and on the left side you have the corresponding LC connector where you can put the patch cables there. So you don't need to worry about, okay, I have a 20-meter connection and now I need a 20-meter breakout cable, And to everybody of you who worked already with these cables, it's very complicated to find the right pairs. The numbering always different on the vendor. So the breakout box is standardized, and you can use the conventional cables very easily there. It's also available as a 2-port breakout box as well, with only 2 instead of 4 breakout cables inside. So here we see it in big, as I said before, breakout cables are included here. 2 versions, as I said, with 2 MPO connectors or 4 MPO connectors. And these are 1/3 of a U height, so you can put 3 of these in 1 U. Okay, so you don't. It's very slim. It's like our optical tabs, the slimline chassis that we use there, and you can put in 3 of these into the racks in 1 U. So let's have a closer look on 400 gig breakout, because this is of course coming up now. Not everybody is well informed here how 400 gig works and what does it mean to use it with 100 gig breakout. So 400 gig uses PAM4 modulation, which is different to the legacy 100 gig modulation, which is called NRZ. Okay, so there's 2 different modulations of the transmitter or the transceiver. This is very crucial difference. So basically, a full passive breakout from 400 gig to an existing legacy 100 gig QSFP is not possible, because the modulation is different. They cannot talk to each other. It requires adaptation from the PAM4 to NRZ modulation. Therefore, there are new 100 gigabit transceivers. For example, they're called 100 gig DR1, FR, or LR. And they have a converter included from NRZ to PAM4. So the electric connector interface is 4 times 25 gig NRZ, the same as the existing legacy 100 gig QSFP modules. The optical output, where you put the cable in, is a 100 gigabit PAM4 optical signal. The 100 gig DR, FR, LR modules include a gearbox chip to convert the 4 times 25 gig NRZ electrical signal to the 100 gig PAM4 optical signal. This is in construct to legacy QSFP28 modules, such as CVDM4, 100 gig LR4 modules, which have 4 times 25 gig NRZ optical wavelengths multiplexer. Okay, so this is the very different QSFPs of a 100 gigabit that are used here. If you have any questions to that, feel free to, in the Q&A session later, to put some questions in. We can, of course, speak a little bit more about it. And everybody who is very interested in 400 gig technology in combination with our products that we have, like the tapping, the packet brokers, of course, we can do follow-up sessions as well. So before I hand over to my colleague Adrian, I would like to quickly cover some, I forget about this. Forgot about this slide, sorry about that. So it's again looking here, the 400 gig to the QSFP28 modulation. So before I hand over to my colleague Adrian, I would like to quickly cover something about traffic filtering, since one of our customers recently asked about it in relevance to this webinar today. So the filtering on our packet brokers, this is correct for all packet brokers that we offer in the meantime, is that we have the so-called 3-stage filtering concept. Okay, so we have ingress filtering, egress filtering, and middle stage filtering. So when the traffic is passing through the unit, we can use loopback function to reinsert the traffic so we can refilter it once again. And all of these filter criteria allow us layer 2 to layer 4 parameters, very conventional, MAC address, VLAN, ether type, the protocol, IP addresses, the UDP and TCP port number, of course, SCTP if required. You can filter out ping messages, TCP flags, and so called. And you have the option on the G5 platform, for example, G5 Plus platform, to select where to put the filter on if you have encapsulated traffic. Encapsulated traffic means you have an IP in IP packet, or it's coming from a virtual environment where these Ethernet headers are stacked and you have multiple IPs and ports. So you can use here the ingress filter mode to select outer tunnel or inner tunnel. This is correct for filtering or load balancing, to define what criteria you actually take into consideration when selecting packets before forwarding it. As I said, this is on the ingress, in the middle stage, and in the on the egress side. So be very flexible here. And to easily reduce data on your analyzing tools or capture appliances, our smart packet brokers like the EXA 48800 or the previous model, the 48200 and the Omnia 120, which are also on the website, they have the deduplication functionality, meaning there's just a button on the web UI that you can enable, and any duplicate packets, which looks exactly the same as the one before, for example, happening from span ports or on some filter, some tapping use cases or concepts that just cause that you capture a traffic multiple times on its way from A to B. The deduplication mechanism can easily be enabled and drops this unnecessary packet. So it's always good to have this on the hand if you need it. Some points you maybe think you don't need it, and suddenly, yes, okay, we have to duplicate packets. It's 20, 30, or even 50% more on my analyzing tool. I need to pay for this additional bandwidth, and with this one single click, you can reduce the bandwidth easily and save cost at the end of the day. There are some parameters on the deduplication. You will see that on the handout. There's a application note about it where you can ignore some parameters as well that allows you to fine-tune this mechanism. For example, a VLAN tag can be different on the duplicate packets, then it's actually ignored by the mechanism, but you can ignore it, as I just said. So it's fine-tunable as well on the relevant use case. Okay, Adrian, over to you.
Thank you, Fabian. So just wanted to kind of take a bit of a different look at the drivers of 400 gig. And, you know, if you've been in the networking business as long as I have, it's a lot of that familiar sort of push and pull. And the push, to a certain extent, comes from the equipment vendors. The modern switch chips, the latest generation of programmable switch chips, you know, have hugely increased capacity. And the reality is that to be able to use the throughput of those switch chips and keep the actual physical real estate down, you basically need to populate a 1RU device with 400 gig cages, literally just to be able to fully utilize the bandwidth available on the switch. So that's the kind of push from the equipment vendors. And again, like I say, this is what we saw going 1 gig to 10 gig and 10 gig to sort of 40 gigs / 100 gig. Now on the pull side, you're seeing obviously a slightly different sort of challenges coming here. And this is certainly still being driven obviously mainly by service providers and hyperscalers. Now the service providers have that more straightforward equation of how much traffic can I get through a given physical capacity. You know, a lot of the exchange points are you know, the colos, you're paying for the real estate you use, and increasingly now sustainability is a key word around the power draw and heat being generated in data centers. So the new technology to minimize that. And, so service providers, whether it be fixed line or mobile, drivers, obviously in mobile, 5G is a huge driver. The potential bandwidth that can be consumed by the mobile subscribers are massively increased over 4G. So there is that capacity element. And there's a big increase in demand as a result of FTTX, so increasingly fiber to the premises, fiber to the home. And an example of that is for a broadband provider here in the UK. They're over a 3-year period, they're projecting a ×3 increase in the volume of traffic traversing their network, but they're only projecting a growth in the subscriber base of 15%. So you can see there is a massive increase in the volume of traffic per subscriber. And that obviously then drives into the deployment of the 400 gig, both in the transport networks and in the data centers. Now, then the hyperscalers and increasingly now, obviously, we talk about these AI data centers. There is still that issue around the bandwidth and the real estate, but then also these guys have more of a concern about latency. And talking back to what Fabian just ran through with the types of 400 gig interfaces, again, this is what we saw with sort of 10 gig to 40 gig to 100 gig. There was perhaps a bit of a perception that going from 10 gig to 40 gig would speed things up, but no, because you were using 10 gig bearers, you were increasing the capacity, but the latency was staying the same because the serialization delay was the same. Whereas with the PAM modulation and the higher speed bearers, you reduce that serialization delay, and so actually increase the capacity, but also reduce latency. And so that's what drives the hyperscalers. And because of course they're more concerned about just fiber infrastructure within a data center, then they can take different decisions around deploying these different types of interfaces. But with all of that, of course, then we are also still faced with this conundrum that we had in those previous evolutions, and that is that typically the tools cannot keep up with that. You can put a 400 gig interface into an x86 server, but does it mean that you can get the traffic across the bus to the host processor and process it effectively? And typically the answer is no. Now, that tends to be more of an issue with security type tools simply because of the kind of processing they're trying to do. But broadly speaking, I think you can still stand by the statement that the processing capacity won't keep up with the volume of traffic. And that's why we need to do all the various breakouts that, again, Fabian was describing, either to run to parallel instances of tools or to be able to filter out spurious traffic so you actually control the volume of traffic that's actually being delivered to those inspection systems. And that's where the Cubro systems come in, the extensive range of the breakouts, both for ingress as the network infrastructure evolves, but also for being able to distribute traffic to multiple instances of tools on the output side. And just to frighten you a little bit more, we are already seeing 800 gig being deployed, so that this problem isn't going away anytime soon. So just wanted, that sort of wraps up the that particular section. So we'll click on to the third question.
Great, thanks then, Adrian. So I guess, just to summarise my understanding of that, again, very interesting points. And in order to sort of handle increasing network speeds and the associated cabling challenges that come with that, really what you need to be able to deliver is latest technology network packet brokers that support actually a wide range of speed connections, but certainly up to high speed, currently 400 gig, that also are able to deliver advanced features such as filtering and deduplication, but associated sort of with elegant and robust cabling solutions. So again, that sort of brings us on to the third question, where we've seen so far very much a theme around, network visibility is a very specialist area with very specialist technology and expertise. the question that we're often asked then is, why Cubro? Why can't I just use a white box solution or an open source visibility tool? So again, gents, if you'd like to pick that up.
Sure, and again, thanks to Fabian, because he set the scene quite nicely for me here with a lot of what he talked about Cubro's internal processes to deliver the quality product that we do. Because of course, why would you look at white box solutions and open source stuff? Well, because it's cheap, isn't it? It's low cost hardware, the free software. So, what's not to like about that? But the mantra here is always about TCO, total cost of ownership. Now, the reality is that it's very, very difficult to truly assess in advance what the total cost of ownership is going to be looking forward over a 3 to 5 year span with a build your own solution. I would contrast this, if you buy a solution from Cubro, you could buy the solution with 5 years of support. And so, frankly, you don't have to worry about, security vulnerabilities appearing, differences in the underlying software, the embedded software, because Cubro takes that challenge away from you. If you're doing a build your own solution, you have all of these various components are all moving, as shown as bullet point, at different speeds. So, but if you're looking at that total cost of ownership, the initial work to perhaps hiring consultants to build the solution day one, you have a very sort of constrained horizon because you have a set of capabilities that you're building towards, and you can easily measure when those have been achieved. And managing by contract, you can deal with that cost and constrain that cost. But that's just getting the solution into place. You've now got to live with that solution for that 3 to 5 year period. And that's when all the bets come off. You've delivered it, you've got the solution into service. But the challenge you then have is moving forward over those 3 to 5 years. Simple things like hardware availability. As I said on the previous slide I was talking to, some of the evolution of hardware is driven by the convenience to the equipment vendors. So that building on a physical platform day one, you cannot be sure that that physical platform is going to be available in 3 to 5 years. I've seen this in the past, simple things with memory chips. You've got 1600 gig DDR4 DIMMs, great. You need some more in the future. That memory vendor's gone out of business. You buy some new ones, it doesn't work quite as well. So that even at the hardware level, you have those challenges. And then when it comes to software, you have obviously the OS, you have the software that you have written to run on top of that OS. And all of those things move at different speeds, and there's nobody out there testing it for you. So you as the effectively the systems integrator, that cost has to be dealt with internally. And the truth is that is very, very difficult, bordering on impossible to predict over that kind of time period. And so while it seems like a marvelous proposition up front and it's wonderfully cheap, the truth is if you do the best effort at a true total cost of ownership over 3 to 5 years, it's going to end up costing you a lot more than maybe you budgeted for in the first place. So really, that's all I wanted to say on this subject as an introduction. So I'll hand it over to Fabian to develop this conversation a bit further.
Thanks, Adrian. Yeah, so let's look at some straight bullet points why to choose Cubro. One, and the most important part, in my opinion, made in Austria hardware speaks for its own, I guess. Everything we can produce in Austria, we do, and 100% of our devices are designed here in Vienna. As we already discussed today, Cubro solutions are tested, certified, and deployed in critical networks worldwide. That ensuring high availability and predictable behavior, unlike open source tools or white box devices, which may require extensive testing and tuning, as Adrian mentioned before. With Cubro, hardware and software comes from the same source, eliminating possible compatibility issues that often arise with white box plus third-party combinations. For what we are known for, very strong and fast support, it is safe to say that Cubro has one of the best support, if not the best in our market. The key team is sitting in Vienna, and all of us, I'm part of it, are technical experts. At Cubro, you're not just a customer ticket number. The support team normally knows your environment, your devices, and your use cases. We are working very closely with our customers, and if possible, the same support engineer covers the same customer at every support case. Cubro helps customers optimize their setups, even when there is no issues. It's hard to get from white box vendors or open source forums. When talking about money, Cubro has always been very good in pricing without any quality advantages to competition. No software or feature licensing. Still, today we don't have that. You get what you buy. We do not use any licensing models for features. You buy the packet broker and everything that is possible is enabled and ready to go. A lot of our customers really much appreciate this simple way to go. Our team includes network experts, as I said already, deeply involved in the visibility and monitoring technologies, not just developers adding features to open projects. Innovations come from actual customers, feedback and market demands, not from community trends or vendor lock-in strategies. That's it from my side.
Great, thanks, then, Fabian. And so I guess what we've heard today, and thanks both to Adrian and Fabian for your input. I think what we've heard today is that network visibility is a specialist area that requires very specialist technologies, targeted products, in-depth expertise, experience, and support for deployment of those successful solutions. I mean, Cubro has extensive experience. We've been around for over 20 years now, actually delivering mission-critical solutions to both service providers and enterprises across the world. So we have very in-depth experience, expertise, and a long history of delivering that capability. And alongside that, we have the robust processes required to deliver those types of capabilities. And that's exemplified, I guess, by the accreditations that we have. And I'd mentioned earlier that we have 27001 and 9001, but we also have the environmental impact accreditation 14001. And what that experience, background, expertise, and robust processes mean is that we're able to develop, deliver, and support secure products and solutions that not only obviously maintain and increase our customers' network security posture, but also help them to maintain their sort of either company policy or regulatory compliance. We're able to help them evolve along with their network speeds, so that we're able to deliver products now that will take them on a journey and help them to retain investment protection. And I guess finally, what we're able to bring together is specialist technology, expertise, and the experience to, again, help our customers maintain and improve their network security posture, help them maintain and improve their network performance, the governance of those networks, the capacity planning of those networks. We help to deliver operational flexibility and the sustainability of those solutions, whilst at the same time supporting a wide range of very specialist, demanding use cases. So that's pretty much concludes what we were planning to cover today in terms of content. And I'll move now to Q&A and ask if there are any particular questions that you would like us to answer now.
If there are any questions, just put them into the chat. I saw one question before. I answered in the chat already. So is there any limitation on the possible filtering combinations on each layers? So no, there's no limitation to combine the filtering parameters. You can freely combine an IP, port, VNI, Ethertype filter on the ingress, and you can put another filter combining layer 2, layer 4 parameters together. So there's no problem with that. There are on the G5 platform, maybe there's a different filter category for MAC addresses, where you can filter a MAC address or a subnet of MAC addresses. This is not combinable with something else because it's their own filter, but you can, of course, do an ingress filter with a MAC address, and on the egress you can put an IP address filter. So you can mix it there again with the 3-stage filtering as well.
Great. Any other questions?
Sorry, Paul. I just need to jump in. I think we have some issues with the slides right now. I will send the slides along with the recording of the webinar, so you all have it, the slides that we used today during the webinar. Thanks.
Great, thanks, Tamana. I just noticed Frank has just asked another question. So it's still the policy of the ports is actual as many ports are needed. Okay. Again, I'm not sure I quite understand the question, Frank. I think is it related to, again, the number of ports on a product? So in terms of capacity, so pretty much nearly all. There's one or two exceptions with our products that when you buy the product, you get all features and all capacity. You get all the ports licensed. We have one or two products, which is specifically the 48200, 48800, and Omnia products, where we've introduced some licensing on the capacity and the number of ports. Obviously, the products ship physically with all the ports, and then it's a license to free up or provide access to additional ports. And the reason we do that actually is to give a low entry level price, but also the ability to scale in terms of capacity. Interestingly, with our higher speed products, the sort of 100 gig, 400 gig, and so on, those typically come with, in fact, there is no capacity licensing on those. Those come with all ports enabled. It's just that I guess at the feeder level, the slightly lower speed products, typically where they're fitting is to support a wider range of ports and probably a higher number of lower speed ports. So that ability to be able to tailor the capacity becomes more important. So hopefully that wasn't too long an answer to just explain our capacity licensing mechanism. And the summary is most of the products, you get all the capacity day one. There's one or two that have fairly simplistic licensing as well. It's not complex. Some simplistic licensing just to increase capacity if you need additional capacity to the capacity that you buy when you buy the product initially. We have another question now from Riaz. Is it possible to filter on layer 7 layers? And a second part, which is for layer 3 and 4 filter capabilities. Is there any limits on the number of rules and bandwidth supported? So can I maybe ask Fabian or?
Yeah. So for layer 7 filtering capabilities, there are a combined answer, let's say. So the shown products today, which is mainly the G5 Plus platform, we support a string filtering mechanism, so you can look up to maybe it's wrong, about 50 bytes. You can look after the TCP or UDP payload and do some user-defined filtering by a string or by an offset there. So you can filter inside of the payload. Our advanced boxes, like an Omnia or an EXA 48200 or 48800, they support advanced version of that by using regular expression, and they can look much more into the packet more than this 50 byte offset. So, and you can you can fine tune that as well, much more flexible. This is the layer 7 filtering criteria that we can offer there. Layer 3 and layer 4 filters. There is, of course, a number of rules that are possible. This depends on the generation, again, device level. So like 5000 is a standard that we have on the G5 Plus. In the normal mode, this can be enhanced as well, up to 16,000 filters. And there's no bandwidth limitation. The bandwidth limitation is the back plane of the device, and we have a non-blocking design, so 100% of the port speed is covered by the back plane as well.
Great, thanks, Fabian. Fritz has also asked a question, in fact, Pramod as well, but Fritz first was, when we apply any policy on, say, ingress and egress ports, the page list downs all the policies configured in the device, the page lists all the policies configured in the device. Can we have this list sorted in an alphabetical sequence based on port numbers? And then Pramod had asked a question, can Cubro packet brokers perform session-aware load balancing and deep packet inspection on encrypted traffic, such as IPsec or TLS? And how do they, excuse me, sorry, my screen has just changed. And how do they handle tunnel termination for protocols like VXLAN or GTP? So again,
the first question, the rules currently are sorted by IDs, in my understanding at the moment. Alphabetically, I must check on one of the latest versions for G5 Plus at least. There is some enhancements on the table there, but I would need to check if you can sort by the comment field or the port field. Actually, the port field is a little bit tricky always because it's a list of ports, typically not a single one. But the sorting by IDs or the comments should be possible. So they need to check on the latest version of the G5 Plus. There was a lot of enhancement there. And can Cubro brokers perform session-aware load balancing and deep packet inspection? So session-aware load balancing, yes, there is a very nice application note on our website. You can check it out. It's just called session-aware load balancing, where we have different types of load balancing, like a session-aware, where we keep the IP sessions together. So it's on the layer 3 or layer 4 base to keep sessions together. Or a second mechanism is the user-aware load balancing. User-aware means we only look at the IP address of the clients, not of the applications or servers. And when you load balance only on the IP address of the user, on the uplink and downlink correctly, then you have the result that all traffic of a specific client or user ends up on the same outgoing load balancing port, which has then advantages for the analytics platform, for example. This depends on the use case, if you need session or user-aware load balancing. Both is supported. Deep packet inspection is a different part. You can check the website here about our solutions, and we can have a follow-up session if you need to. It's too short in time that I can answer that. And for encryption traffic, it does not matter because load balancing is only looking on the IP header as well. And how do they handle tunnel termination? Depends. Yeah, the question is a little bit stacked. If it's related to DPI, as said, we can discuss it in a separate session. For load balancing, we have a mechanism to have inner IP load balancing for VXLAN or GTP specifically. So this is covered by our packet brokers to look on the inside header, especially for GTP. Even for a VXLAN GTP packet, this is possible by our 3-stage filtering, where we have to remove the VXLAN header. And then the GTP packet is completely free, and we can look at the inner subscriber IP address of the GTP for the mobile network. This is possible, yeah. Okay, switching from phone to tablet, no, not able to connect. Sorry about that. You need to check the laptop. Yeah, hope your questions answered. Paramount, if you, it's just labeled as a message if you have any follow-up question on TPI. It's a very complex topic, that's why I don't want to cover it too much now.
Great, thanks. And Fabian, are there any final questions we can answer today? Otherwise,
I just got one more feedback from one of my colleagues in the chat about the sorting of the filtering, about the rules. Good point is you can download the rules via Excel. This is on a G5 Plus platform, and in Excel you can of course sort it a little bit differently than maybe the Cubro UI gives you. But if you have any concrete feedback, the issues that you have on the rule table there, please let us know. It depends very much on your Cubro packet broker generation and the model you're using. Yeah. But just leave us a message if you have any concrete feedback. Support.cubro.com for everybody. As I said, best support in the world. I just say it. Yeah. Thank you everybody. Thank you everybody for joining. Listening.
Great. Thanks, and thanks, Fabian. Thanks everybody for your time today. Really appreciate it. Hope you have a good rest of the day or evening, wherever you are, in which time zone you are, and hopefully you'll join us for the next one. Thanks again.
Thank you.